Hi everyone, welcome to Petrosys webinars. My name is Benna Spinks and today we're going to take a look at what's new in Petrosys 17.7. Please note that this webinar is being recorded as the video will be uploaded to our website at a later date. If you do have any questions, then please feel free to ask them once the webinar has finished. So our agenda for today, we're going to go through an introduction to the new key features. I'm then going to run a demonstration to show you these features in action, and we'll finalise with a summary. So, introduction to the new features. Under Mapping and Visualization, you now have the ability to contour on the fly when displaying your grids. This means that you no longer need to have contours generated for your grid in order to display them on your map, as Petrosys can now do this on the fly. In Display GIS, under Thematic Mapping, you now have the ability to display directional annotations. So for example, you can use dip and azimuth data for this. In the Spatial Editor, you can now merge your overlapping buffered shapes. And in a 3D viewer, we now have the ability to display fault sticks and fault surfaces. In Surface Modelling Volumetrics, we've integrated a new grouping layout into surface modelling in 3D viewer. This replicates the same layout as the display list in mapping and allows you to create and edit groups. We've added additional polygon clipping options to the Clipping tab under the Gridding option. This means that you're no longer restricted to a Petrosys polygon for your clipping. Under Velocities in Surface Modelling, we now have a new well-checked shot depth conversion option. This option is used to automatically create grid arithmetic tasks to perform depth conversion based on a formula which is generated from the intersections of your well-checked shot surveys and also your formations or zones. We now have the ability to direct connect in Windows to OpenWorks and SizeWorks. This eradicates the requirement for a dispatch server. Petrel is now available as a new feature class option in the Spatial Editor. We've expanded our import and export options. This now includes an export option for OpenWorks to directly export to an OpenWorks grid. Under the CRS option, we have text file CRS conversion. This means that you can now convert the coordinates for a large number of data points stored in a text file all at once, rather than having to do them in small batches. So we're going to move on and discuss the data that we're going to use today. So the data set that we're going to have a look at today is going to be a Petrosys demo data set, and it's the Targa data set. So now let's move on to the demo and we can have a look at these features in action. So we're going to start in mapping. So on my map I have some well data and some seismic data for Targa. What I'm going to look at first is the contouring on the fly option that's new. So under display, I'm going to put a grid onto my map. As you'll see in the display grid window, I now have a new tab which is called Contours. So I open my grid file that I want to use and I can now get Petrosys to contour on the fly. I don't have Targa two-way time contours, but I want Petrosys to do this on the fly for me. So I'm going to come under the Contours tab, tick on Display Contours and choose my increment. If I wanted to specify a single contour level, then I would do so under here too. So I've set the increment to 20, and I click OK. Petrosys has now gone off, it's displayed my grid, and it's done my contour increment of 20 on the fly. I'm now going to have a look at the Display GIS Thematic option, and we're going to have a look at the new Directional Annotation. So in this case, I have my strike and dip data stored in an Excel spreadsheet. So I'm going to open the Excel spreadsheet, double check I'm happy with the format of my X and Y columns. I'm going to turn my Z column off in this case. The next thing I need to do is specify a shape. Because I'm going to use strike and dip data, I'm going to choose an arrow. I'm also going to change the line width and the line size to make sure that it will display correctly on my map. The next thing I'm going to do is set my annotation. So in this case, I want to show my dip values. So I'm going to choose dip and move it across to my selected attributes. I'm also going to change some of the display features to make sure that it displays correctly my map. In this case, under Set, I'm going to change the decimal places. As we're displaying dip data, normally you would display 0 decimal places for your dip information, but for the purpose of this demo, I'm going to leave this at 1. The next tab I need to fill in is the thematic mapping. So under here, you now have the option to use symbol style for your enable thematic. So because I've chosen an arrow under my shape, it's going to use that in my symbol style options. So I now have the option to choose against orientation, color, length, and width. In this case, I just want to use the orientation as I want to show my dip direction, but I could also apply color gradients to this, or I can display the data based on length or width. If I click on preview, you can see I've got my chosen arrow. It's also given me an example of some of the information that is being used. So now when I click OK, go back to my grid, as you can see, my directional arrow and annotation says my dip values have now been displayed on my map. We're going to move on, have a look at the new features under the spatial editor. So under Create New, we now have Petrel as an option for your new feature class. So you choose Petrel, connect to your project, change the parameters as required, and click OK. We're going to have a look at the buffer zones. In this case, I'm going to open a well data Excel spreadsheet that I have. So this is my target well information that's being stored in my Excel spreadsheet. I'm going to click OK, and the data is now displayed on my map. What I want to do is I want to create buffer zones around these well points. So under Operations, I choose Buffer Shapes. Select your distance, check all the rest of the parameters. In this case, I want to create an output file, and I've chosen to create a shapefile. So I've given it a name. I'm happy with the parameters. Now the new feature in 17.7 is this Unite Overlapping Shapes. So at first start, I'm going to toggle it off and click Apply. And as you can see, I've created my buffer zones on my map. Now, if I toggle this feature on, what it's going to do is it's actually going to merge the overlapping shapes together. So when I click Apply, you can now see that those merged shapes have now been merged together. So what I can then do is I can take this file and I can save it, and I can then go into surface modeling and I can use this as a clipping option. So I can clip based on these buffered shapes. If I'm not happy with any of the shapes, then I can delete them using the attribute table. I can toggle them off, I can then resave the file, or I can use my spatial editor toolbox and I can delete them. So we're now going to move on and have a look at the the surface modeling. So I have a task file already open. As you can see, the workflow itself looks a little bit different in 17.7. This is because I now have the option to create and edit groups. So what I've done in this workflow is I've created some groups and I've then put my tasks under the groups. I'm going to have a look at the new clipping options. So under Grid, Create Grid, in your Clipping tab, if you toggle on Clip Grid, under Polygon Clipping, you can now see that I have a whole host of spatial options available to me, not only a Petrosys polygon file. So to tie in the workflow that we just covered in mapping, what I could do is I could choose Shapefile, and I could click and choose that buffered wells shapefile that I created and use that as a clipping polygon for my grid. The next feature we're going to have a look at is under Velocities, and it's the new well check shot depth conversion option. So under well data source, you have a host of options available to you. In this case, I'm going to stick with a Petrosys WDF. You can choose data selection files if you wish. Under zone selection, you need to choose a data type. In this case, I'm going to choose zone top. You also then need to choose a zone. I'm going to use the V formation in this case. Once I've chosen my zone data type and my zone, the information in the window is populated to correspond with these options. Under the line of best fit equation, by default it's set to linear, and that gives you an example of the equation being used. You do have additional options under here that you can use as well. If I click on Analyze Data and Chart, what it's going to do is open a new chart window. I can choose these different options based on the different columns available to me. I also have tabs available to me. For example, I can change the title and plot, so I can change the name. I can also change the line of best fit. So again, under Analyze and Chart, linear is the default type that's been chosen, but I do have other options available to me. So because I have linear chosen, the line of best fit is based on the linear equation. If I change the type, the line of best fit will now correspond with the type that has been chosen. So if I revert back to linear, what I can do is I can actually click and look at my individual points. Now, as you can see in the left-hand side, when I click on a point, it becomes highlighted in red to give me a little bit more information about the point itself. So, for example, if I decide that these two outlying points should not be included in my equation of line best fit, I can actually highlight them, right mouse button, and exclude the selected points, so I can remove these from the equation. As you can see in the left-hand side, they are now greyed out as they are not being included. If I decide that I want to re-include them, I can right mouse button, re-include all points, and the points are then added back into the equation and the line of best fit is redrawn to match. If I'm happy with the chart and I am happy with all the points being used, I can close the window. If I wish to export this chart, I can use the export options under here, so I can export to a raster image, a PDF, and I can also export direct into a PowerPoint presentation. So back in the window, there is a Create a Linked Depth Conversion Arithmetic Task option. If I toggle this on, it's going to ask me to specify my input to a time grid and also give an output depth grid. When I click OK, this is going to prompt the Grid Process Arithmetic window to open. Now, as normal, the formula is specified at the top. This can be edited, and the variables have also been defined from the formula. If I'm happy with these and the output geometry, I can click OK and run the task. We're now going to have a look at the 3D viewer. So again, I have a 3D viewer file already open, and as you can see, again, I have new group options available to me. So if I right mouse button, you can see I have the Create Group option, which is that same functionality that's been available in the display list and mapping all along. So what we're going to have a look at is the new display options. So under display, we now have the option to display fault sticks and also fault surfaces. If you look at my image, I already have fault sticks on here. So what I did is I came into display. I chose my data selection input. In this case, I have a Doug Insight project. Connected to my project, chose my data type, toggled on the fault sticks that I want to use, and clicked Apply. So back to the main Petrosys launcher. We're now going to have a look under CRS at the new text file CRS conversion option. So I have up here, I have an input file of Targa wells in a text format, but I know they have the wrong coordinates assigned with them. So as you can see, I've got CRS defined here. Output file, I have the corrected file name, and I have a different CRS. So I'm going to change these from zone 50, which is incorrect, to zone 51, which is correct. So I do, check the format, make sure I'm happy, check all the other parameters, click Apply, and that entire list of coordinates will be changed from one reference system into another. Now have additional import and export options available to me under the import and export menu options. In particular, one of interest, under Landmark, I now have the option to export direct to an OpenWorks grid. As previously mentioned, we can now direct connect to Landmark for OpenWorks and SizeWorks on Windows, so you no longer need to have a dispatch server set up. So now let's return to our presentation. So as you've seen, there's a lot of new and exciting features in version 17.7. If you would like to have a look at the release notes, these are available on the Petrosys website or can be provided if you contact Petrosys support. Thank you for your attention. Hope you've enjoyed this webinar. If you have any questions, then please feel free to ask them now, or you can contact support@petrosys.com.au. Thank you.